welcome to Homeschool. This is your class 10 mathematics. Today in this session we are going to discuss MCQs on circles. Let's see the first one. In the adjoining figure, TP and TQ are the tangents to the circle with center O. You can observe the figure here. TP and TQ are the tangents to the circle with center O. What is T there? T is an external point. Any tangent drawn from external point, that tangents are perpendicular to the radius through the point of contact. So according to that, I can say this angle will be 90 and this angle will be 90. 90 plus 90, 180. The sum of opposite interior angles of a quadrilateral is 180. You can see quadrilateral, right? This angle 90, this angle 90. 90 plus 90, 180. What about another opposite pair of angles? It will be 180. While sum of the quadrilateral angles will be 360 degree. Therefore, if this is 110, what does this is your question? You need to find angle PTQ. In 180 degree, subtract 110 degree. That will be 70 degree is angle PTQ. Check the option. It is option C. 70 degree. Second one, in the given figure, APB is a tangent to the circle from point P. PQ is a chord. So here APB is a tangent from point P to the circle with center O. And PQ is a chord. If angle BPQ is equal to 62 degree, angle BPQ means only this angle. This angle is 62 degree. You need to find angle PRQ. Where is PRQ? This angle we need to calculate. Observe the figure carefully and understand first. This angle if you need, first I need the central angle. Why? Double this angle is central angle. Do you know the relation? This angle double will be central angle. So if you are able to find this, if you do half, you are going to get angle PRQ. Before finding this angle, we will be finding other angles. This angle and this angle. So first we remember, if B is an external point, tangent drawn to the circle through the point of contact is always perpendicular. How I can say this point? By theorem. So from here, see here, observe carefully. From here to here, angle is 90 degree. And only this part is 62. Only this part is 62. Find this angle. Find this part of the angle. That means from here to here it is 90 minus this angle you subtract 62. That will be 28 degree. Okay. If this is 28 degree, then what about this? You can observe here, OP and OQ are the radius of a circle. Radius, always they will be equal. If these two sides are equal, what you can say? Opposite angles are equal. This is 28 degree. Then this angle will be 28 degree. Add 28 plus 28, it will be 56 degree. Now find this angle. This looks like a triangle, OPQ. Sum of the interior angles of a triangle will be 180 degrees. So add this, 28 plus 28 will be 56 degree. In 180, subtract 56 degree in order to get the central angle. 180 minus 56, it will be 124 degree. We got the central angle. Now it is very easy to find. Half of 124 degree. It is 62 degree. Therefore angle PRQ is 62 degree. Check for the option. Option D, 62 degree. So in this way, we need to think about the angles. Which angle we know, which angle we can find first to get that answer. Okay. Third one, in the figure, O is the center of the circle. AP and BP are the tangents at point A and B respectively. If angle OAB is equal to 30 degree, then the measure of angle OBA is, observe the figure, P is external point, AP and BP are the tangents to the circle. Immediately I remember this angle 90 and this angle will be 90. And they have given angle OAB. Angle OAB. This angle. This angle is how much? 30 degree. I am writing here 30 degree. Then what about angle OBA? What is the measure of angle OBA? This angle we need to find. To solve this problem, we no need of bothering about tangents. Observe only the radius. OA and OB are the radius. AB is a chord. Right? Radius, both the radius length will be equal. If these two sides are equal, then their opposite angles are equal. It looks like a triangle, right? OAB. If two sides are equal, their opposite angles will be equal. According to that, this angle is 30 degree. Then this angle will be 30 degree. Check for the option. Option A, 30 degree. In figure, they have given 60 degree just to confuse you. Fourth one, three circles with center A, B and C touch each other as shown in the figure. You can observe this figure. With A as a center, you imagine one big circle. And with B as a center, next circle. C as a center, third circle. A, B, C touch each other as shown in the figure. If the radii of these circles are 8 centimeters, 3 centimeters and 2 centimeters. Okay. Which might be 8 centimeters radius? A. I think this radius will be 8 centimeters. From here to here or here to here you can say it is 8 centimeters. And next 3 centimeters. Which circle you can see? This is smaller. I cannot say this 3. This one is 3 centimeter. 3 centimeter from here to here, and you can see this side also 3 centimeter. And next coming to 2 centimeter, this is the circle. Okay, what is your question? Find the perimeter of triangle ABC. Perimeter of the triangle ABC. That means sum of 3 sides AB plus BC plus CA. By observing figure, you need to find this length and this length. If you know these two lengths, you can see the perimeter of a triangle. Observe carefully. From here to here it is 8 centimeters. And I don't want this length. That means in 8 centimeters, how much we need to subtract? This is nothing but the radius. In 8 centimeters, subtract 3. 8 minus 3 will be 5. 8 minus 3 will be 5. And already you have 3 here. Then here we need to write 2 centimeters. Now add this 2 plus 3 plus 3, it will be 8 centimeter. But I need only AB side. AB length is 2 centimeter plus 3, that will be 5 centimeter. Now coming to BC, 3 plus 2, 5 centimeter. And we need to calculate CA. Same manner, from here if I join, this becomes a diameter. And this is also a radius. This will be 2 centimeters, right? I don't want this part. From here to here it is big circle radius, that is 8 centimeters. In 8 centimeters, subtract 2. 8 minus 2 will be 6. From here to here it is 6. Already you have in the circle radius 2 centimeter. 6 minus 2 again you do. It will be 4 centimeters. From here to here 4 and from here to here it is 2. Now add all the sides. AB plus BC plus CA. AB 2 plus 3, 5. And BC 3 plus 2, 5. And CA 2 plus 4, 6. It is 16 centimeters is the perimeter of the triangle. Observe here, this length you need to subtract. Then only you get AC side. And here also you need to subtract this length. So therefore, what is the perimeter of a triangle ABC? It is 16 centimeters. And your option is option B, 16 centimeters. Fifth one, you can observe this figure. In the given figure, APB is tangent at P to the circle with center O. APB is a tangent to the circle from point P with the center O. Okay? And what did they give here? If angle QPB, where is angle QPB? Angle QPB, this angle is 60 degree. Then the measure of angle POQ is measure of angle POQ. Same manner, don't be confused. Where we have done second problem, similarly we need to think. B is an external point and P is a point of contact, right? Tangent is always perpendicular to the radius through the point of contact. That means here, observe the point. From here to here, it will be 90 degree. First, try to find this angle. 90 minus 60, it will be 30 degree. If this is 30 degree, then what will be this? It will be 30. Why? OP and OQ are the radius of the circle. Okay? So, if these two sides are equal in a triangle, their opposite angles are equal. Then, angle OQP is also 30 degree. We need to find angle POQ. For this triangle, observe carefully, sum of the interior angles of a triangle will be 180. 30 plus 30 will be 60. 180 minus 60, it will be 120 degree. What is angle POQ? 120 degree. Check for the option. It is your option C. 120 degree. Sixth one. In the given figure, AB, BC and AC touch the circle at L, M and N. Let us see. AB, BC, CA touching the circle at L, M, N. And what did they give? If angle B is equal to 70 degree. Angle B 70 degree and angle C 60 degree. Okay. Then what is the measure of angle LON? This angle you need to calculate. Okay. See here. This is a circle with center O. And ABC is a triangle. Triangle touching the circle at L, M and N. We need to find LON. We can do in two ways. That is, sum of interior angles of a triangle is 180. Add all the three angles and say equal to 180. I don't know angle A, find angle A first. 70 plus 60, 130. 180 minus 130, it will be 50 degree. This is 50. Observe carefully. A might be a external point to a circle. AN and AL will be tangents. What are tangents? It is touching at one point of a circle. I say that A is an external point. AL, AN are the tangents. Then this 90, 90, 180, 50 degree. Then opposite angle 180 minus 50 will be 130 degree. Therefore, angle LON is equal to 130 degrees. Or another method you can choose. If B is an external point, BM and BL are the tangents to the circle. Then this angle 90. Then the opposite angle, this angle and this angle sum will be 180. 180 minus 70 will be 110 degree. Okay. So I may write this as 110 degree. If I consider C is an external point, again same manner C and CM are the tangents, then that is 60. Then this angle will be 180 minus 60, it will be 120 degree. And now complete angle of a circle is 360 degree. Now 110 plus 120. 120 plus 110 will be 230 degree. In 360, you subtract this 230, it will be 130 degree. Any way you do, you are going to get same answer. Either you can add the angles of a triangle and then find angle A. Then after getting angle A, these two angles, sum will be 180. In 180, subtract this angle, you are going to get this. Or you can go with B as external point, C is the external point, find this angle, find this angle. Coming to this circle, complete angle is 360. So we know 110, 120, add these two angles. In 360, if you subtract, you are going to get this angle. Anyway, you can proceed this, and finally your answer is 130 degree. And your option is option D. Option D, 130 degree. Seventh one, two circles of radii 8 cm and 5 cm with their centers A and B touching each other externally as shown in the figure. You can see the figure there. The length of direct common tangent PQ is, two circles are touching externally means like this, and having radius 8 cm and 5 cm. This is called as a direct common tangent. Two circles are lying on the same side of a line touching at one point of a circle. Then we call that PQ as a direct common tangent. Suppose if two circles are lying on opposite line of the circle. See, this is a line. Suppose your circles are lying like this. Then what do we call this line? This line is called as a transverse common tangent. And this is direct common tangent. We need to find the length of PQ. This circle radius is 8 cm. This is 8 and this is also radius 8 cm. This is 5 cm and this is also 5 cm. They have given a line. Using this line we can find the length of PQ. Or I may go with another method. That is, see, this is 5 centimeters, right? Here 5 centimeters I try to join here. This length is 5 centimeters. In 8 centimeters, subtract 5 centimeter. Then this small part length will be 3 centimeters. Okay? And now, see, this is 5 and this is 5. Then it shows a rectangle. What is this length? It is 5 plus 8, 13. Then this length will be 13 centimeters. Okay? And now, tangent is always perpendicular to the radius of a circle. See, only this triangle I am trying to take it out. So, this will be little cross like this it will be. And now, hypotenuse is 13 centimeters. And this length is 3 centimeters. What is this is your question. Now, apply the Pythagoras formula here. This is P, Q. Let me take M. PM square is equal to PQ square plus QM square. PQ square is equal to PM square means 13 square. 13 13s are 169. And this Q1 square, bring this side, 3 3s are 9. That means minus 9. PQ square is equal to 160. PQ is equal to square root of 160. Whereas 160 is not a perfect square. So split this one. 16 tens are 160. 16 is a perfect square. Bring it out. 4 4s are 16. 4 root 10 centimeters. What is the length of direct common tangent PQ? That is 4 root 10 centimeters. Check for that option. It is your option B. Option B, 4 root 10 centimeters. Eighth problem. You can see the figure over there. Tangents PQ and PR. PQ, PR tangents means P is an external point. That is a circle with center O. To a circle from an external point P if PQ is equal to 9 centimeter and angle PQR, this angle is 60 degree. Then the length of the chord QR is. What is length of QR is your question. Angle PQR is 60 degree. What is the length of the chord? Chord you can see here, QR is a chord. Okay, QR length we need. Observe carefully, if this is a tangent to the circle with center O, tangents are equal. By theorem what we can say? These two tangents are equal. PQ is equal to PR. Observe here, PQ is equal to PR. If these two sides are equal, then observe PQR triangle, their opposite angles are equal. Then this is 60, this will be 60 degree. They have given that angle and this angle is also 60. 60 plus 60, 120. But total sum of interior angle of a triangle is 180. 180 minus 120. How much it will be? 60 degree. You can see an equiangular triangle. All the three angles are equal. Then what we can say? All the three sides will be equal. Therefore, PQ is 9 centimeter, QR is 9 centimeter and PR is also 9 centimeter. Check for the option. Your option is option C. Option C, 9 centimeter. Ninth one. In the given figure, TA and TB are tangents drawn from the external point T. PQ is another tangent at S. If the perimeter of a triangle PTQ, triangle PTQ, perimeter means sum of all the three sides, PT plus TQ plus QP is equal to 20 centimeter. Find the length of AT. Find the length of AT we need to calculate. So they have given perimeter. Perimeter of triangle PTQ is equal to 20 centimeters. Perimeter means PT plus TQ plus QP. Okay, is equal to 20. Now observe carefully. If TB and TA are a tangents, I can consider P is also an external point. Okay, suppose if I consider from this point, P is external point and these two becomes a tangents. PS, PB are tangents. I know from an external point, tangents length will be equal. Therefore, what I can say? PS equal to PB. And if I consider Q as an external point, AQ is equal to QS. Okay, don't be confused. They have given the perimeter of a triangle. We need to find side. Let us see. This PQ, I may split it as PT plus TQ plus, see here, this QP, I split it as QS plus SP is equal to 20. Okay. Now, instead of QS, I write QA. Instead of QS, I write QA. And instead of SP, I write BP. Okay. Instead of SP, I write it as PB. Now, PT plus TQ plus QS means AQ and SP means PB is equal to 20. Now, what is AQ plus QT? Is nothing but AT. AQ plus QT is nothing but AT plus PB plus PT. PB plus PT is nothing but big line BT is equal to 20. I know if T is an external point, again these two tangents are equal. Which tangents? T and TB. Therefore, instead of BT, I write it as AT. Why AT, children? You can write BT, no? No, they have asked us question 80. So instead of BT also you write it as 80. 80 plus 80, 280 is equal to 20. 80 is equal to, divide this 2 here, 2 tens. Therefore, the length of 80 is equal to 10 centimeter. Understand the question carefully. The perimeter of this triangle given. They have given 3 tangents, AT, BT and PQ. Okay. So, it is touching at S we know. Again, P becomes external point. PS and PB be the tangents. The tangents length will be equal according to the theorem. Here also QA and QS will be equal. Then given triangle perimeter is equal to 20. That means PT plus TQ plus QP is equal to 20. Instead of this, you write this one. Then again, this tangent is equal to this tangent. Okay. So, therefore, 2 times 80 equal to 20, 80 equal to 20 by 2, it will be 10 centimeters. Check for the option. It is your option B, 10 centimeters. 10th one, in the given figure, you can see the figure over there. AC, CE, EH are tangents drawn to the circle at B, D and F respectively. If CB is equal to 5 centimeters, if CB is equal to 5 centimeters and EF is equal to 3 centimeters, then the length of CE, what is this length is your question. This is very simple. Observe here, AC, CE and EH are the tangents given at point B, D, F set. Suppose if I take C, C is an external point to the circle, right? CB, CD is also a tangent. CB is equal to CD. What is CB length? 5 centimeters. So, therefore, CD is also 5 centimeter. Then coming to E. E is also an external point. EF, ED become the tangents. EF is equal to ED. From an external point, tangent's length will be equal. EF is 3 centimeter given. Therefore, ED is also equal to 3 centimeters. Now, add these two and say complete length of CE. 5 centimeter plus 3 centimeter will be 8 centimeters is the length of CE. Okay. So, which option is the right answer? It is option D, 8 centimeters. Option D, 8 centimeters. 11th one, two circles of radii 5 centimeter and 3 centimeter touch each other as shown in the figure. The distance between their centers is. Observe the figure here carefully. And they have given the radius 5 centimeters and 3 centimeters. Observe carefully. A is the center of big circle and B is the center of small circle. Okay. In the figure, they did not give A and B. But I have written A and B in order to understand for you. So, look here. If A is center, this one. 5 centimeter. Observe carefully. Small circle radius is 3. And this side also it will be 3, right? 3 plus 3, 6 centimeters. This circle diameter will be 6 centimeter. But big circle radius is 5 centimeter. 5 centimeter means extra 1 centimeter will be here for small circle. Once again I repeat. Small circle radius is 3 centimeters, then diameter will be 6 centimeter. And big circle radius is 5. Suppose from here to here. Okay. So now, what is the distance between two circle center? By saying this, what is the length of AB? Observe here, from here to here it is 5 centimeter. And from here to here it is 3 centimeter. 5 centimeter minus 3 centimeter will give you 2 centimeters. So, when they ask like this problems, Directly subtract the radius of small circle and radius of big circle. That is 5 minus 3. 2 centimeters is the answer. Check your answer here. That is your B option. Option B, 2 centimeters. 12th one, in the given figure, TP and TQ are tangents drawn to the circle with center O. TP, TQ are the tangents drawn from the point T to the circle with center O. If angle PTQ is equal to 40 degree, angle PTQ, this angle is 40 degree. Find angle OPQ. OPQ means this angle you need. By theorem, we can say that tangent is always perpendicular to the radius through the point of contact. Okay, this is a tangent and OP is a radius. This from here to here it will be 90. But I don't want complete 90 degree. I need only this angle. Okay. So in order to find that angle, first we need only this angle. How can we find that angle? Observe here, PTQ as a triangle. We know that tangents drawn from an external point, length will be equal. If these two sides are equal, then their opposite angles are equal. If I take this x, this is x. Okay. X plus x will be 2x. 2x plus 40 degree is equal to sum of the interior angle of a triangle is 180. 40 degrees and other side. 2x is equal to 180 degree minus 40. That will be 140 degree. X is equal to 140 degree by 2. It is 70 degree. Now this angle I got it as 70 degree and this will be 70 degree. This is 70. Now it is very easy. What is this angle? We know from here to here it will be 90. Okay. So in 90 degree, subtract 70 degree, you get this part. See, angle you should observe very carefully. 90 minus 70, it will be 20 degree. Okay. So this small tiny part is 20 degree. 90, in 90 we got here, this is 70, then this part is 20. So check for the option. It is option C, 20 degree. 13th one, in the figure, AP, PC and CD are the tangents to the circle. Observe this figure. AP, PC and CD are the tangents to the circle. Okay, let me mark this is center O. Now, if AP is equal to 3 centimeters, similar problem we have done, right? And PC is equal to 8 centimeters. Before problem, we found this length. Now, they have given this length, we need to find CD. What is the length of the tangent? CD. So, observe here carefully. If I take P as an external point, PA is equal to PB. So, this is 3 centimeter. This will be 3 centimeters. How I am saying? The length of the tangents from an external point to a circle are equal. So, by theorem, I say that the tangents length will be equal. Therefore, PA is equal to PB. Therefore, this is 3. This will be 3. And from P to C, PC length is 8 centimeter. In 8 centimeters, subtract 3. It will be 5 centimeters. Again, if C is an external point, CB is equal to CD length. By theorem, what you can say? CB is equal to CD. If this is 5 centimeter, this will be 5 centimeter. So, which option is your right answer? Option C, 5 centimeters. 14th one, in the given figure, chord AB is equal to chord CD is equal to 8 centimeter. That means you can observe in this figure, AB is a chord, CD is a chord of length 8 centimeters. Chord length is 8 centimeters. That means we should remember a point. What is that? The chords, if they are having equal length, then they are equidistant from the center. They are equidistant from the center. And what did they give here? OX is equal to 3 centimeter. OX 3 centimeter set. Then what about OY? OY is also 3 centimeter. Equal chords are equidistant from the center. Radius OC. What is radius OC is your question. See carefully, here perpendicular set. Then I can say this is also perpendicular, right? Yes. If this is perpendicular, I can see a right triangle. Right angled triangle. Okay. So, center, the chord is bisected. That means, if this is 8 centimeter, then CY length will be 4 centimeter and YD length will be 4 centimeter. Now, you can see a perfect right triangle. Apply Pythagoras formula for this. That is, OC is a hypotenuse. OC square is equal to OY square plus CY square. OC we don't know. OY 3, 3 3s are 9. CY 4, 4 4s are 16. 16 plus 9 it will be 25. OC square 25. OC is equal to square root of 25. That is 5 centimeters. What is the radius of the circle? 5 centimeters. Check for the option. It is option B, 5 centimeters. 15th one, they have not given figure. We need to draw the figure. So observe carefully. The length of the tangent drawn to a circle of radius 3 centimeter. I have drawn a circle with radius 3 centimeter. Tangent from a point. Where I need to put a point which is at a distance of 5 centimeters from the center of the circle. From here, 5 centimeters away from center, we need to put a point. Already here 3 centimeters there. So extra 2 centimeters I take, and this is a point, external point. Okay, observe here carefully. Find the length of tangent. Is it a tangent? No. P is external point. O is the center. I need to draw a tangent. Imagine this is a tangent. We need this tangent length. We know by theorem, tangent from an external point is always perpendicular to the radius through the point of contact. So for that purpose, I just go on drawing a dotted line and put a letter A. What is OA? OA is a radius. Radius is how much? 3 centimeters. And I know this length, external point is 5 centimeters away from the center. Angle A is right angle. I can say a right angled triangle. Again, I apply Pythagoras formula. That is, OP becomes hypotenuse. OP square is equal to OA square plus AP square. OP 5 5s are 25. OA 3 3s are 9. AP, I don't know AP. Bring this 9 this side. 25 minus 9 will be 16. AP square is equal to 16. AP is equal to square root of 16. It is 4. Therefore, length of the tangent is 4 centimeters. Okay, where is your answer? Option D. Option D, 4 centimeters. 16th problem, in the given figure, you can observe the figure there. Angle PAO is equal to 30 degree. Where is angle PAO? Yes, PAO. This angle is 30 degree. Then the measure of POQ is, POQ means I need this angle. They have given angle PAO angle and we need to find angle POQ. By theorem, I can say that tangents drawn from an external point, their lengths will be equal and subtends equal angles at the center. That means this angle equal to this angle. Anyway, we can prove this. I go with considering this triangle. Tangent is always perpendicular to the radius through the point of contact. That means this angle is 90. Now in this triangle, find angle POA first. Sum of the interior angles will be 180. That means 90 degree plus 30 degree, it will be 120. Now these two angles sum is 120. And what about this angle? 180 minus 120, that will be 60 degree. By theorem I can say subtends equal angle. Only this angle is 60, then this also will be 60 degree. Okay, 60 plus 60. Therefore, angle POQ is equal to 120 degree. Okay, only this angle given. By theorem statement I say this is 90 plus 30, 120. Interior angles of a triangle 180 minus 120 will be 60, and it subtends equal angles at the center. If this is 60 and this will be 60, total 60 plus 60 will be 120 degree. So which option is the right answer? Option B, 120 degree. 17th one. In the figure, you can observe this figure. XP, XQ and XR are tangents to the circles given. Observe carefully. X is external point, okay. But from there, 3 tangents arrived for 2 different circles. From an external point, we can draw only 2 tangents. But here, not only one circle, another circle also there. If the length of XQ is 9 centimeter. If length of XQ is 9 centimeter, then the length of XR, this is your question. Observe first big circle. If that is a circle, X is external point, which 2 tangents are equal? XQ is equal to XP. By theorem, we can say that tangents drawn from an external point length will be equal. That is, from here, for this big circle, XQ is equal to XP. Then this will be 9 centimeters. Okay, forget about big circle now. Observe only small circle. X is external point. For this circle, what are the tangents? XR and XP. Again, tangents from an external point length will be equal. Then XR is equal to XP. XP is 9 centimeter. XR is also 9 centimeter. Okay, don't be confused. For big circle, if this is 9, this will be 9. And again, small circle is also touching at same point. Therefore, XP is equal to XR. XP 9 centimeter. XR is also 9 centimeter. Check for the option. Option C, 9 centimeters. 18th one, in a circle of radius 10 centimeters. Observe, this is a circle of radius 10 centimeters. OB is a radius and it is 10 centimeters. O is a center. OP perpendicular to AB. OP perpendicular to AB. If OP is equal to 6 centimeter. Okay, then the length of chord AB. What is this length is your question. Clearly, you can observe a right angle triangle there. Apply Pythagoras formula. OB square is equal to OP square plus PB square. OB 10 tens are 100. OP 6 are 36. PB we don't know, PB square. 36 bring this side. 100 minus 36, it will be 64. PB square is equal to 64. PB is equal to 8. Right? What is PB? Did they ask us PB length? No. Chord length. Chord OP is perpendicular to AB. From center, if we draw a perpendicular to the chord, it divides equally. If this is 8, this will be 8. Therefore, what is the length of AB? 8 plus 8, it will be 16 centimeters. Check for the option. Option D, 16 centimeters. 19th one, if two circles of radii 4.5 centimeters and 3.5 centimeters are touching externally. Okay, let me draw two circles. This is 4.5 centimeter circle and this is 3.5 centimeter circle touching external limits like this only. Okay. So, what is the distance between their centers? Observe here. If the distance you need, you can directly add, no? 4.5 centimeter plus 3.5 centimeter, that will be 4.5 plus 3.5 will be 8.0. 8.0 or 8 centimeters. Check for the option. You have option A, 8.0 centimeter. Option A, 8.0 centimeters. 20th one, O is the center of a circle. All is chord here. Observe, AB is a chord, AC is a chord, BC is also a chord. You know which is the biggest chord in a circle? Diameter is the biggest chord. Okay, AB, AC, BC are all three chords. And what is angle ACB is your question. Angle ACB. Do you know any one of the angle? Don't know. But observe carefully, children. You can see here diameter. We know from areas of circles, we can say minor segment angle, major segment angle. Observe here. Actually, we don't have this here. See, this is minor segment. Minor segment angle is always obtuse angle. And in major segment, all the angles will be acute. Acute means less than 90. Obtuse means more than 90. And whereas I can see a diameter here, that means this circle is divided into two equal segments, that is semi-segment. The angle formed in semicircle is always right angle. See here, this angle is always right angle. You need to remember this as this point is covered in areas of circles. That is not there this here. So remember, angle formed in minor segment is obtuse angle, major segment acute angle, semi-segment right angle. What is angle ACB is your question. If this is 90, then remaining two angles sum must be 90 degree. So let us go with the options here. Angle ACB 90 degree? No, 90 plus 90, 180. Then what about this angle? No, it cannot be first option. So go with B, less than 90. Yes, less than 90. So suppose if this is 80, this might be 10 degree. If suppose it is 70, it might be 20 degree. So it will be less than 90, but it is not 90. Okay, I go with B option, but let us see C option also. Greater than 90? No, not at all. Option D, 180 degrees? No, never. Only a single angle in a triangle can never be 180 degree. Okay, therefore, which option is the right answer? That is your option B, less than 90 degree. Option B, less than 90 degree. To solve MCQs in circles, it takes more time. Whereas each and every problem explanation is time consuming. So I tried to do 30 questions extra I am going to give for you for the practice. If you have any doubt in any problem, you can just text me in the comment box. These solutions I am going to forward you in Telegram link. You can check in it. With this, I am going to end the session. In our next session, we are going to meet with another new chapter. Until then, keep watching. Thank you all.